Let's get started on 5.5. 5.5 is similar to the previous section where you have to graph and find solutions, but this is inequalities. So this is inequalities and systems of inequalities in two variables. So I have an illustration of what it might look like right here. Suppose you have like some sort of line like that, and then a parabola, and then those are your two equations, or inequalities, that is. And then you'll have a greater than or less than symbol, and then you basically shade regions. You shade basically above, and then maybe below. And then the overlapping region will be the solution. And then the other critical piece is to find these intersection points. Okay, so that's kind of the process. So let's take a look at an example. So for example, graph the solution is what it'll be stated. So the solution is going to be basically a region or a set of ordered pairs, but it's the only way to really describe it effectively is by graphing. So the system may look something like this. Suppose you have y greater than 1/3 x minus 2, and y is strictly less than x minus 4. So let's suppose you had that inequality, and what we do is we first graph the equality. So you basically pretend it's equals and graph that. So you're going to graph y is equal to 1/3 x minus 2. So that's just a line. Slope of 1/3, intercept at -2. And then we graph y equal to x minus 4. Okay, so you read off the slope, right? That's just 1/3. M is 1. Your y-intercept is 0, -2 for the first one, and 0, -4 for the second. So you graph those. Oh, and let's make this an equal. So that's a less than or equal. So I want to show you the difference. But first you just graph them both. Effectively, let's just say it like this. The first one will be solid. Okay, so this is a solid line, and this will be dotted because of the strict inequality. So basically, if you have the equal to, that's solid line. If you have the strict inequality like that, that is dotted. So just know that and you're good to go. So we got to graph those. So draw in a coordinate system. I'd like to have that still white. Draw in your coordinate system. It's going to be shifted down, so I'm going to move the x-axis up a little bit, like that. And let's graph these in different colors for the fun of it. So we're at -2, so down 1, 2. And then you have a positive slope of 1/3, so up 1 and then to the right 3. Up 1 and then 1, 2, 3. Up 1 and then 1, 2, 3. So that point, we actually know what it is. It's 6, although you just need to graph that. So we can go down 1. So let me show you. I'm counting it off. So you're here at -2, and then I went up 1, and to the right 1, 2, 3. and then up 1, 1, 2, 3. And there's a delay, so I'm trying to, maybe that worked better, I don't know. Okay, so then you draw in your graph like that, and this one is solid. With this thing, what I usually do is draw it solid anyway, and then I just go in and make it dotted later. So just erase. You can do the same thing with a pencil. Okay, so there's your solid line. And you want to label some of these. This is -2. And then let's graph our next equation. You're down at 4, -2, 3, 4. And you have a slope of 1. So you're up 1 over 1, up 1 over 1, like that. Okay, so I'll go way up here. and you can see that that graph is like this. So I'm going to come back and make it dotted. And then from there, same idea. Okay, so let's make it dotted. Like that. So with pencil, you can go and erase it, basically. Alrighty. Now, what about this intersection point right here? Is that intersection point a circle or a dot? Because every point on this line, the first one, satisfies the inequality, and then the points on this line don't quite satisfy the inequality, but you're really close. So think about that. Do you include it or not? So the answer is you don't. So you don't include it because it's not included in the dotted one. So it has to be included in both. So right there, that intersection is going to be a circle. And we need to find that intersection. We will do that later. Okay, so we got two things to do. So first, I write this down. Well, write all this down, but to find the intersection and that could be plural, of graphs. So it's graphs of the equations. Let's just write it all out, I guess. What you do is you set the equations equal and solve. Every time. Set the equations equal and solve. Okay. So we're taking these two equations up here and you're setting them equal. So you're saying 1/3 x minus 2 is equal to x minus 4. And that'll tell you the x value of intersection. So get everything on one side, add 4 on both sides, and you get 2. And then you get x minus 1/3 x, add that together. So it's 3 over 3, so it's 2/3 x. And so you get 2 is equal to 2/3 x. And then multiply through by the reciprocal, and you get 3. So x is equal to 3. Now you could actually, on this one, count it out. It's pretty clear. Like you did the graph pretty nicely there. So that's going to be 3, and then if it wasn't obvious, like this one is, this is just -1. But if it's not obvious, you substitute back to solve for the other variable. So in this case, for y. So to substitute back to solve for y, you'll just say y is equal to, and then you pick one. So it's just going to be 3 minus 4 is an easy one, is -1. So 3, -1, which you can count this one off on the graph pretty easily, that you know is the intersection. Okay, a few more points to label. That was -4. That's pretty much all you need. So you need to have those. And then we got to figure out which way to shade. Do you shade up or down? Now this is the fail-safe way to do this. So that's what I like to call this. This is the fail-safe method. You won't get confused whether the inequality is on the right side or the left side, or the equations, or y, basically. Y doesn't have to be on the left side, it could be on the right side. This works every time. So the fail-safe method is this. You choose a test point in a region not on the graph. So not on the graph. So basically take the green graph, and that breaks up the region into the upper half and the lower half. So you choose a point. If you can choose 0, 0, that's what you choose. It's the easiest one to choose. Okay, so choose 0, 0, the origin, if not on the graph. Okay, and then what you do, so then substitute into the inequality. So you substitute back to the given inequality. So way back up here, substitute into either one. Well, whichever ones we're working on, right? I mean, this is your y is equal to 1/3 x minus 2. This one is your y equal to x minus 4. So you want to label those so you know which one's which as you're working. Okay, so we're going to do that and see what we get. So if you substitute in, so in other words, that's your test point. Okay, so you choose, there it is. I knew I wrote that down somewhere. Choose a test point. Okay, so we choose 0, 0 if you can, and then substitute into the inequality. So we're going to test 0, 0, and you can see you get 0 is less than or equal to, let's go back up there, -2. Okay, so you're picking this value right here, and that is true. And then you pick 0, 0 again, so you put in right there, there's up there, go look. So you choose 0, and what do you get? Strictly less than -4. True or false? It's false. So the first one, okay, when we tested, we got a true statement. So you would shade towards that region, like that, everything up here. So that's all of these points above the graph satisfy the inequality. Okay, so I have that statement here too. So if true, shade that region. Shade the region the test point is in. If false, shade the opposite. So shade the opposite region. Okay, so what you get is the overlapping region, and I'll just go ahead and shade it here. Let's use blue, I guess. And you get this region. Okay, so check that out. Make sure that makes sense. Okay, so this is the region we're shading. Okay, so all those points in the middle, not including the top one, but including the bottom graph, satisfy the system. Okay, so that's the method. Now, what you can do, and I hesitate little tricky things on anything I do, but if y is isolated on the left side, which it is, then you can just use the inequality. So that your y values are greater than the line. And then, so that means you're shading up, right? So that's the green one. You're going up. And this one, again, it has to be on the left side, and you read it left to right. Your y values are less than the line. Think of that as the line. So that's going down. Less than is down, like that. So the overlapping, of course, is there. Okay, so I went through that pretty carefully. Let's do another one. They do take some work. Let's see, how many do I have left? We do another one. Well, let me go ahead and do another video because I'll go much faster on the next two examples, and that's all I was going to do tonight for this section. That's pretty much all you'll need. Okay, so I'll go ahead and pause that, and we'll do two more examples, but I won't go through all the little details since we already have them.